Today's topic is domain and range. So please put the title domain and range in your notes along with today's date. And the target statement, I can determine the domain and range of a function. In parentheses, it says or a relation because there are some things that we will look at that are not functions. And we will discuss that as we approach those. But your main target is to determine the domain and range of a function. You might remember this part right here from the beginning of our unit. The beginning of our unit, we use this definition for a domain and range. The domain is the set of all input values. Today, slightly different, but it means the same thing. The domain is the set of the first numbers in the ordered pairs. The domain is all of the x values, which is what we said here, x values, domain. Then we have the range. The range is the set of the second numbers in the ordered pair, or the y values, which we stated a little bit differently when we started the unit, that the set of the y values is called the range. But what you need to know is that x, the first number in an ordered pair, is part of the domain, and y, the second number in an ordered pair, or the output, or even f of x, is the range. So we're going to look at this list of ordered pairs, and the first thing we're going to do is determine if it is a function. To determine if it is a function, the first thing we do is we look at all of the x values. So we've got -2, -1, 0, 1, and -2. Wait a minute. There's a -2 right here and a -2 right here, and they have different outputs. So is this a function? No. To be a function, each input has only one output, or the same output every time it is input. When I input -2 and get 7, later I input -2 and get 1. This is not a function. However, I can still list the domain. The domain is the set of the x values, or the first numbers in the ordered pairs. First, I'm going to do scratch work. I'm just going to list them. -2, -1, 0, 1, and -2. It is preferred that you put them in order of least to greatest, and you do not have to put repeats. So I do not have to put the -2 again since it's already in there once. So I'm going to list them as a set from least to greatest: -2, -1, 0, and 1. That is my domain. For the range, I look at the set of second numbers. So again, I'm going to do scratch work and just list them: 7, 5, 3, 1, and 1. I also have a repeat in the range. I have 2 1s. I don't have to list them if they show up twice. However, it is best to list them least to greatest. So I have more rearranging to do on my range. 1, 3, 5, 7. That is least to greatest. So that is my range. If you just have a list of pairs, you just list the numbers that are in the domain and the numbers that are in the range. So here's a second example like that. First, I need to determine if it is a function. So I look at my x values: -7, 3, 0, -2, 6, -6, and 4. There are no repeats on my domain, so yes, this is a function. For my domain, I'm listing all of my x values least to greatest. First, my scratch word: -7, 3, 0, -2, 6, -6, and 4. That's the list. I notice that -7 is the least, so I'm going to start with -7, then -6. I'm going to mark those off as I go. -7, -6, -2, 0, and then 3, 4, 6 is pretty easy, least to greatest. That is my domain. all of the first numbers in the ordered pairs or all of the x values. For the range, first I'm just going to make a list of them. 20, 5, 5, 0, -4, -9, and 4. I have 2 5s, so I don't have to list that twice. I'm going to start with my lowest and go to the highest, so -9, -4, my negative numbers first, and then 0, 4, 5, and 20. 0, 4, 5, and 20. That is my range, or the set of all the second numbers in the ordered pairs, or the y values. You might also see it as a table. So I'm going to look at this table. This is a little bit easier to determine if it's a function. I just look straight down at all of my x values. And when I'm looking at all of these x values, I notice that there are no repeats. So I will say that yes, this is a function. And for the domain, it's already listed, least to greatest. So I just put it in the set 0, 1, 2, 3, 4, 5. And for the range, it in this table happens to be also listed least to greatest. So I just copy it in the set. And this is my domain right here, all of the x values or the inputs. And then my range, which is all of the y values or the outputs or the second numbers in the list. You could also have to determine if it is a function by looking at a graph. And we have talked about the vertical line test. Since I have separate points on this graph, I need to draw a vertical line through each one just to test and make sure it's not going through 2 points. So here's a vertical line, 1 point, another vertical line going through 1 point. And each time I draw a vertical line here, it's only going to go through 1 point. So is this a function? Yes. What gets a little bit harder here is listing the domain and range. Since I have a graph, remember the domain is the x values, least to greatest, and the x-axis goes left to right, least to greatest. So I'm going to remark my points as I talk. So the first point right here in line with the x-axis is in line with -2. And the next one, -1. The next one's actually in line with 0, then 1, then 2, then 3. To find the range is the set of the y values, and the range actually goes least to greatest from down to up. So I'm going to start on the lowest points, and I'm going to remark them as I go, and then start moving up. So I have 2 points. The lowest 2 points I have are in line with -1 on the y-axis. So -1. As I move up, the next one is in line with 0 on the y-axis. Moving up, this one's in line with 2 on the y-axis. And these last 2 are in line with 3 on the y-axis. Now you'll notice that the list in my domain is longer than the list in my range. They do not have to be equal. You just want to list them least to greatest. Here's another one. So I first want to try the vertical line test to determine is this a function or not. And as I draw my vertical lines, goes through 1 point, goes through 1 point, 1 point, 1 point, 2 points, I can stop and say this is not a function. No, it is not a function. The vertical line test would only be going through 1 point at a time. So it's not a function, but we can still list the domain. The domain is all of the X values. So domain starts from left to right, X values. And I'm going to go least to greatest, so that's left to right. So I'm going to start over here. The first one is in line with -3, then -2, then -1, 0. I have 2 in line with 1, then 2, then 3. Those are my X values, the set of the domain. To find the range, I do very similar, but I am looking at the Y values. So when I'm looking at the Y values, I'm going to be looking from least to greatest, and that's going to be down to up, or bottom to top. So I'm going to start at the bottom. On the y-axis, the lowest one is in line with -2. The next one's in line with -1. Then I have one and another one in line with 0. Then I have one in line with 1, another one in line with 2, and another one in line with 3. So 1, 2, 3. So when you're checking from a graph, you want to say, what is it lined up with on the X? That's the domain. What's it lined up with on the Y? That's the range. You want to put them in order, least to greatest, as I have in the sets. But then you have graphs like this that are made a figure of a connected line. And so we don't really have time to list all of the possible ordered pairs. And here's what I mean. There's an ordered pair right here. This is 1, 2. But there's also an ordered pair right here, which is 1.52. And there's another point, 1.62, 1.72. Over here, I've got -1, and that looks like maybe 1.7. And then I've got -1.5, and maybe that's aligned with 1.3. So when I have a connected line, I do not try to list all the ordered pairs. I just try to say what is the lowest, what is the highest, and in this case, it can be written as an inequality or as an interval. First thing I want to do is I want to talk about the domain being left to right. So the farthest left, so this is the left, the farthest left that this line goes is -2. The farthest right that this goes is to the 4. As an inequality, I can say X can be between -2 and 4. And I do notice that those are colored in dots, so I'm going to say or equal to. X is in between those, and the colored in dot includes the or equal to. In interval notation, this would be a bracket from -2 to 4, also having a bracket. For the range, it's down to up. So I'm going to say, how low down does this go? The lowest that it goes down is -2. The highest that it goes up is +2. There is a closed circle on -2. So this is Y. And +2 doesn't have a closed circle, but there is part of the line there. It's not any open circles along this where it's in line with 2. So I do also say or equal to when I talk about that +2. For interval notation, for the range, I would go from -2 to +2 with brackets because of the closed circles and the included points. So you can list them as we did on our first examples, but when it's a connected line and there's too many to list, you can write it as an inequality or as an interval. So we're going to do a couple more of those. Here's another one. Remember, domain is left to right. So the furthest that this picture goes to the left is -4. And the furthest that it goes to the right is +4. So I'm going to put X in between, and they should both be facing the same direction. On -4, I'm going to include an equal sign because it has a colored in dot. And on +4, I will not include the equal sign because of the open dot. To put that in interval notation, there would be a bracket on -4, but a parentheses on +4. For range, I'm going down to up or bottom to top. The lowest that this goes is -3. And the highest that it goes is +3. I will still put Y in between two inequality symbols. -3 will have an equal sign because there is a solid dot down at -3, but +3 will not have an equal sign because there is an open circle at the top. Interval notation will put a bracket on -3 and a parentheses on +3. Now let's talk about this one. It does seem to have a closed circle, but it has arrows at the ends. So we have to know what's happening at those arrows. So when I start to talk about the domain and I'm saying how far to the left does this go, this arrow would make it go and go and go. So it's actually going to -infinity. A similar thing happens when I try to see where it stops on the right. This arrow would make it go and go and go. And so it's actually going to +infinity. For the inequality, I can put X in between -infinity and +infinity. And I can put it in interval notation. Remember, infinities, positive and negative, just get parentheses. But what I want you to know is this statement here. If the inequality or the interval has infinity on both sides, you can just say all real numbers. So for this one, the domain is all real numbers. Now let's talk about down to up, which is the range. For the range, this does have a low spot. It stops at -1. But as I go up and I try to see where's the top, looks like this arrow is higher. However, it would go up and up and up. So it is going up to +infinity. For the interval, I put Y in the middle, infinity on the right, of course. The -1 does have a colored in circle, so it gets an equal sign. And when I put this in interval notation, I could say -1 to infinity. And I need you to make this note. If the inequality has infinity on one side, you can write a shortened inequality. So, -1 to infinity is the same as Y is greater than or equal to -1. Anything bigger than -1 on up to infinity. Here's another example. I'm going to give you this one and one more after, just to make sure you have time to think about left and right and down and up. So on the domain, the farthest left that this goes to is -2. And the farthest right that it goes is an arrow, which is infinity. -2 gets an equals underneath the inequality because it is a closed circle. And infinity does not. It's kind of like the parentheses. It doesn't get that equal sign. My interval would have a bracket and parentheses. And remember, if you only have infinity on one side, you can write a shortened inequality. So with infinity on one side, you could say that this is x is greater than or equal to -2. It is actually part of the inequality. So let me show you that part. It is this part of the inequality. X is greater than or equal to -2. I just put the x on the left-hand side. So once you have infinity on one side, you can just write that one part. Let's talk about the range now. How low does this go? My picture's a little bit sloppy, but it's meant to go down here to -1. But going up, on one side I do have a closed dot, but it does go higher than that over here at the arrow. And since it's an arrow, we're going to infinity. My inequality would be the interval could be, and remember, once again, I have infinity on one side, so I can shorten that to this one part of the inequality, this one part right here. However, with writing x first. So I would write x. I would keep it open to the x, so open to the x. And sometimes you will see that shortened, so watch out for that. Here's another and our last example. I've got an arrow on the left and an arrow on the right. So my left is -infinity and my right is positive infinity. That inequality from -infinity to positive infinity, and that interval, -infinity to positive infinity. Remember, if you have both infinities, you could just say all real numbers, or a multiple choice option could say all real numbers for that scenario. For the range, there seems to be an arrow here, but it's not going below -1. It's not continuing to go down. So I do have a down limit of -1, and I have a top that's not going above +1. So my inequality would be between -1 and +1. And what I notice is there's solid lines, no circles. So I'm going to use the less than or equal to because the solid lines are not showing me any open circles. For interval notation, that would give me brackets at -1 and at +1. And that is our last example for domain and range.